How's it going, everyone? Welcome to Quarantine Science. Today we're going to talk about a topic in chemistry. We're going to focus on the periodic table of elements, and we're going to talk about how the organization of the periodic table will tell you how an element is structured. And more that the element structure is why the organization of the periodic table is the way it is. This video is going to cover 4 learning targets in total. We will talk about first the review. Just give a basic review of structures of an atom. The second thing we're going to talk about is just what the basic info in an element box represents. The third thing we're going to talk about is the significance of groups and periods when it comes to the structure of an element. And then the last thing we're going to do is we're actually just going to draw a simple element given the information in an element box and its location on the periodic table. That is its group number and its period number. Okay, here's our short review. Atoms are made up of 3 subatomic particles, protons, neutrons, and electrons. You can think of each of these things as portions of a magnet. Atoms are kind of like magnets in the sense that they have positive and negative components associated with them. Protons would be the positive component in an atom as they have a positive charge. They have a mass in that they weigh 1 atomic mass unit. They have a mass of 1 atomic mass unit, and they are found in the nucleus of an atom, that is the very center of an atom. Neutrons are also found in the center of an atom, and they also have a mass of 1 atomic mass unit, but they have a 0 charge here. Neutrons and protons both found in the nucleus. You can think of neutrons as the glue that holds protons together. If you think of magnets, if you took 2 magnets and tried to stick them together with their positive ends, they would be more apt to want to push each other away based on their magnetic pull. Protons are kind of the same way, but neutrons kind of help glue them together so that they stay grouped together inside that nucleus. The third subatomic particle are electrons, and these have a negative charge. And what else is different about these is they're organized into energy levels outside the nucleus. Much of the periodic table is organized based on the organization of electrons, and we're going to talk about that. Another difference that electrons have from protons and neutrons is they are virtually weightless. They have 0 mass almost. They do have a very, very tiny mass. If you do know what the mass of an electron is, I encourage you to post that in the comment section below this video, and I'll pin one of the correct answers up to the top if you're the first one. This large letter in the center of an element box, that's the atomic symbol. This is just the shorthand 1 to 2 letter thing that represents that particular element. Got the name usually written somewhere in there that tells you what that element is if you can't figure out from the atomic symbol. This number that's down here at the bottom, that might be in other locations on the element box. This is the atomic mass. And you know this number is the atomic mass because it will usually be bigger, and it will be written out to multiple decimal points, and that scientists have done lots of averages to figure out to that level what the mass of a hydrogen is. One of the other numbers is the atomic number. This is just another number used to identify an element. Hydrogen, in this case, it's the number 1. And then other numbers you might see on some periodic tables, or at least such as this one, are group numbers and periods numbers. You will find these on the outside of the box, and they just tell you the groups or the rows. So in this case, hydrogen has a 1 next to it, and above it, this tells you that it's in group 1, period 1. The atomic number represents the total number of protons in an element's nucleus. It also represents the number of electrons an element has in total. The number of protons and electrons that a stable atom has will always be the same as each other. So if you looked at the atomic number, from there you should be able to figure out the number of protons and the number of electrons in an element. So when we go and draw an element later, you can figure out how many protons you need to put in its nucleus and the number of electrons you need to draw just by looking at the atomic number. Now, with the atomic number, you can figure out the number of protons and electrons an element has. If we take a look down here, for our example, hydrogen has an atomic number of 1. Looked from our example from back before, that would tell you that it has 1 proton and 1 electron. That's all on the atomic number. The next thing we're going to talk about is the atomic mass. That was that number that was drawn out to several decimal places. In this case, 1, 2, 3 decimal places. This is the atomic mass. This is the total number of protons and neutrons that is in an element's nucleus. When we talk about protons and neutrons make up the bulk of a mass of an atom, they represent the atomic mass. So if I knew the number of protons and the number of neutrons, you could add that number up and you could get a relative atomic mass based on that information. We'll talk about really quick how to find the number for neutrons, but I want to move on to the atomic symbol, which was that big letter H that we saw in our hydrogen. The atomic symbol is just a 1 to 2 letter symbol used to ID an element in shorthand. This is usually derived from its Latin origins. Now, hydrogen seemed pretty straightforward. Put an H there. That stands for hydrogen. That was pretty straightforward. Sodium, however, and some other elements are exceptions in that what we know as sodium has a symbol called Na. That's because its Latin origins comes from the word natrium. And we use Na to represent natrium, which is what they called sodium way back when it was first discovered. Okay, given this information, we've figured out how many protons, or how to tell how many protons and electrons an element has. Now we want to figure out how many neutrons an element has if we were given this information. And we can do that by using the atomic mass and the atomic number. Now, to find the number of neutrons in an element, we just have to follow this simple formula, which is we take the atomic mass, round that mass to the nearest whole number, and subtract the atomic number from it. So in this case, we had hydrogen. I'm going to pull out my periodic table again just to show you. If we went and looked up the atomic mass of hydrogen, we would see that it's 1.008. So we would write that down. We would write a minus sign, and we would write the atomic number of hydrogen. Looking that up, you can find that right there is the only whole number written in that box. And that atomic number comes out to 1, so we'd write 1 there. We would subtract the atomic mass and the atomic number from each other, and we would get no neutrons is what we would get from that. That is the number of neutrons inside the nucleus of a hydrogen, the most common hydrogen at least. This isn't the case with every element where you get, if you subtracted the atomic mass and the atomic number, you'd get 0. So let's take a look at another element. Another element is lithium. Lithium has an atomic mass of 6.94. So we're just going to write 6.9. That rounds pretty closely to 7. We would subtract lithium's atomic number. So if we looked it up again, lithium has an atomic number of 3. And if we go 7 minus 3, we come out to four total neutrons in lithium's nucleus. That is 4 neutrons in the most common type of lithium's nucleus. Periods, we talked about those. Periods represent the rows of the periodic table, and groups represent the columns of the periodic table. So we'll take that again, this periodic table. Every group is these vertical columns here. Every row is these horizontal rows, or period, excuse me. Every period is a horizontal row going down the periodic table. Now, periods represent the number of electron energy levels an element has. And I wanted to take a moment and show you how we would draw that. An energy level we would just draw as a circle. So I'll draw it down here. If this is the nucleus down in here with all the protons, neutrons, electrons, just pretend this is a lot of protons and neutrons. This would be an energy level with electrons going around it. And every single layer on top of that would be an energy level. In this case, period 1 has 1 energy level, so we would just draw 1 energy level. Period 2 has 2 energy levels, so we would draw 2. Period 3 has 3 energy levels, so we would draw 3 energy levels there. 1, 2, and 3. Groups represent the number of electrons in the outermost energy level. Now, each element has the same number of protons as it does electrons, But these electrons are going to be organized in a certain way, and its outermost shell will tell you how that particular element will interact with other elements. So group 1, every element in group 1 will have 1 electron in its outermost shell. Group 2 will have 2 electrons in its outermost shell, and group 6 would have as much as 6 electrons in its outermost shell. Okay, hydrogen. We went and looked it up on our handy periodic table here. Its atomic number is 1. That means it has 1 proton. Its atomic mass is 1. So if we took atomic mass 1 and subtract that from the atomic number, we would find that the number of neutrons is 0. So we only have to draw no neutrons. So when we draw our hydrogen, we take that atomic number, draw 1 little proton there. And there's going to be 1 electron, since there's only 1 there. So we only got to worry about 1 energy level. If we didn't need to worry about that at all, if we wanted to know for sure, this is in period 1, which means it only has 1 electron in its outermost shell, or excuse me, it only has 1 energy level, and it's in group 1, so it only has 1 electron in its outermost shell. So we'll draw a little energy level here. That is our electron. We'll call that a proton, and we'll call that good. Okay, let's take a moment and try lithium. To make this go a little bit faster, I'm just going to reference numbers from before really quick and kind of go through this quickly. Lithium, its atomic number written right there is 3. Its atomic mass is 6.9. So we'll just go 6.9 minus 3. That comes out to 0 neutrons. We'll go ahead and draw the protons and neutrons first. Or excuse me, that's not 0. Good thing I caught that. That is 4. Let's do math. 6.9, and we got to round that to 7. Bad science teacher. I'm not editing this. We're just going to keep going. 7 minus 3, that comes out to 4. I promise I have degrees in sciences. That comes out to 4. Okay, so we'll take a moment. We'll actually draw all these out. So we'll draw 3 protons. We'll make these the protons. And then we'll draw 4 neutrons. So there's 1, 2, 3, and 4. Okay. Dots are neutrons, circles are protons. Now, lithium, the atomic number is 3, so that it's going to have 3 electrons, but we need to figure out how to draw these in the energy levels based on what we know about the group number. So lithium is in group 1, period 2. That means it's going to have 2 energy levels, and in its outermost shell it's going to have 1 electron. And here's how you go about filling it up. In this first row, this represents the first energy level. So we'll draw that first energy level. This first energy level represents 2 elements that reside in there. So there's going to be 2 electrons in that energy level. Then we get to the second energy level. We will go ahead and draw that. And we're just going to count the number of elements in this row until we reach lithium. And since it's right here in the first one, this group 1 means this is in this outermost shell here, it's going to have 1 electron. So we'll draw that right there. Okay. If this isn't straightforward yet, we're going to draw one more, and I'm going to draw a few more examples in another video of just pure examples in case you need help with it. And for this one, we're just going to focus on aluminum just to get one more in. So aluminum, if we take a moment and look on our periodic table, aluminum has an atomic number of 13. and it's got an atomic mass of, that might be hard to see, but that's 26.98. So 26.98, that rounds to 27. So AM is 27. We'll just write 27 here. 13 is the atomic number for protons, and we go 27 minus 13, so that's gonna, let's get this right this time, 7, 6, 5, 4, so that'll be 4. I know I could probably do this in my head, but let's not do that. 2 minus 1, so we got 14 neutrons. I am not going to take the time to draw that just for the sake of time, so what we're going to do is we're just going to write 13 protons and 14 neutrons. 13 protons because the atomic number for aluminum is 13. 14 neutrons because if we took the atomic mass, rounded to the nearest whole number, and subtracted 13 from that, the atomic number from that, we get 14. And we'll call that good. Okay, this one's a little bit more down the periodic table, so we're going to have to do a little bit of kind of looking to figure out how all these electrons are organized. Now, we already know the number of electrons that aluminum has. It's got a total of 13 that we were able to tell from its atomic number, but now we need to figure out how many energy levels it has and how many electrons go into those energy levels. Okay, let's start off with this first energy level. This is going to be the same as lithium here. So if we look at this first energy level in this first group 1, there are 2 elements in that first row. So there are 2 electrons that go in that first energy level. Now, let's move on to the second period, the second row. Now, aluminum is in the third row, but we need to count all of these electrons that go into here so that we know how many electrons go in the second energy level. There are 1, 2, 3, 4, 5, 6, 7, 8 electrons in this second energy level. So we're going to draw 1, 2, 3, 4, 5, 6, 7, 8. Awesome. All right. Now we get to group 3, which is where aluminum is. We draw our third energy level. And we just count how many elements in aluminum is until we get there. There are 1, 2, and 3. 1, 2, 3. And its outermost shell. Okay. Covered 3 examples there. I'll make another video that is just me showing this if I need to. Based on comments, it just like if this didn't get covered quite enough, I want to make sure that my videos help you as much as possible. So let's go ahead and do a quick lesson review, which I will end every video with. First thing is, what are the 3 subatomic particles that make up an atom? Where are they located? What are their net charges? What does the atomic number, the atomic mass, and the symbol represent for an element? What do group numbers and period numbers represent for an element or elements in that group or period? And the last thing I want you to do is I want you guys to draw helium, carbon, and sodium based off their formation given in the periodic table. Try and do that best you can from the information that you know about in the periodic table, and then check yourself by looking it up on the internet afterwards. Don't just look it up off the internet. We want to test ourselves and figure out where we went wrong. If you can't quite figure it out, then maybe rewatch the video and see if that helps. Okay, that's it for today's lesson. I hope you found this helpful for your content or your classes. Those you students, teachers that might be watching this video, I'll be uploading videos as often as I possibly can. And yeah, have a great day. Thanks for watching.